Okay, well, today's lesson is going to be about solving right triangles. Kind of start out hopefully with a little funny for you. So let's talk about first, what does it mean to solve a right triangle? That's our goal in this lesson. So solving a right triangle means that we find the measures of all of the sides and all of the angles of a triangle. All right, so we're going to just work to find the measures of the angles and the side. So how do you find an angle measure when you have two sine measures? That's what we're talking about. Well, we're going to use on a calculator that sine inverse, the cosine inverse, and the tangent inverse that you might see on any scientific calculator. And I'll be showing you on a graphing calculator, but it shows up on all calculators. So let's look in a graphing calculator where we would find it. We'd actually find it, the graphing calculator, our sine inverse, you have to hit second to hit the sine inverse. And you can kind of see here how you see the sine inverse there. Or if we wanted to see cosine inverse, we go second cosine inverse. So you've probably seen this on several different scientific calculators. So let's look at the problem. In a right triangle, if A equals 17, and C equals 32, find D. Now, we have to remind ourselves that C is always our right angle in a right triangle situation, always. The A and the B doesn't matter, but what is important is that across from angle A is that lowercase excuse me. Across from angle B is lowercase b, and that's really important. So here we have a right triangle ABC. C is going to be your right angle. I know some students got that wrong on the last test. And it really doesn't matter where A or B goes. You can kind of switch them around. Because what you need to know is if lowercase a is 17, that's this angle. And if lowercase c is 32, that's the hypotenuse. Oh, and I have a typographical error here. I think this was going to say find, let's say it says find B. Okay, so we want to find angle B here. We want to know what is the measure of this angle. For that angle, this is my opposite side, or excuse me, I made a mistake. This is my hypotenuse here is 32, and my adjacent side is 17. Okay, so we have hypotenuse and our adjacent side. So what we're going to do with that is hypotenuse or adjacent and hypotenuse is cosine. So the cosine of angle B is 17 over 32. Now, it used to be we were saying to ourselves, okay, the cosine of what value is 17 over 32? What we do is this is where we're going to go then. That means the inverse cosine of our answer, 17 over 32, equals our angle B. All right, so that inverse cosine is kind of how we do division, like when we're dividing on both sides, we're trying to figure out. So the inverse cosine is saying, okay, the cosine of what value is 17 over 32? So we want to find the inverse cosine of 17 over 32. So we're going to go back to our calculator. This is convenient. We have inverse cosine already there, and we're just going to say 17 divided by 32. And you don't have to have your parentheses, but you definitely can have your parentheses here. So we got an answer of 57.91. So we're going to go back here. We're going to say, well, our answer was that B is 57.91. We're just going to leave it at 57.9. So we found out that angle B is about 58 degrees. Let's look at our next example here. All right, so now in this right triangle, MNP. Now, we don't know in this case which one is our right angle here, and so that was really important. Assume, since like here the ABC at C is the right angle, we're going to assume that in MNP, P is our right angle. So always kind of assume we're going to start here MNP. On a test, if it's not an ABC, I really should tell you this is the right angle. In fact, on a test, even when it's ABC, I should say, oh, and C is the right angle, and here I should have said NP is my right angle, okay? So here's my P, here's my M and N. So N equals 15, that's what we're told here. M equals 8, and we need to find angle N in here. We need to say, what is this angle measure, okay? For angle N, the 15 is the opposite, and the 8 is the adjacent. So opposite and adjacent is tangent. The tangent of N equals opposite 15 over adjacent 8. All right, that means you're just going to have to take the tangent inverse of that 15 over, 8. And that's what our angle n is going to be. That's going to be the measure of angle n. Tangent inverse of 15 over 8. So we're going to go here. Oh, I'm trying to make it work here, sorry. All right, tangent inverse, we're going to go second tangent of 15 divided by 8. That's 15 over 8. I'm going to hit enter. 61.92. And again, we could probably say, oh, that's really close to 62, but we'll leave it at 61.92. So we're going to say our answer, our angle n, is 61.92 or 62 degrees. I would have accepted probably either one, 62 or 61.9. Okay? So that's really what we're going to be doing over and over again. We're going to be doing this, solving right triangles, finding all the side lengths and all the angles. So here in this problem, we were told, hey, find this, find n, find b here. Okay, excuse me, sorry about that. And then now we're going to be looking at it saying now we need to solve it. And if you remember just from when we had the intro, the solving is finding all the angles and all the sides. So what do we know? We know that side A is 21. We know side, oh, and I have a typo there. Let's call it, I'm going to call it side C is 30. Excuse my typo. So I'm going to say this is 30. I need to find all the angles and all the sides, all right? So I still need side B, I need angle A, I need angle B. Now, I already know angle C is 90 degrees, all right? So that's kind of partway there. Well, the first one that occurs to me that's probably the easiest to solve is for side B. Side B squared plus side A squared, which was 21, has to equal 30 squared because of the Pythagorean theorem. Okay, well, 21 squared is 441. 30 squared there is 900. And then we have B squared, which means my B squared would be, excuse me, I'm doing a calculator work here, 459. Okay, let me see if that has a square root. It doesn't. All right, so we're going to just call it here square root of 459. It actually comes out to 3 square root of 51. So we're going to say B is a square root of 459, and we can just leave it like that. All right, I want exact values here. So I'm good when it comes to the sides. We found all 3 sides. We already were given A, we're given C, and here is B. So we found all 3 sides. Now let's work on the angles. I don't care which one you go to, whether it's angle A or angle B next. I'm going to start with angle A. So in order to solve for angle A, I'm going to say angle A, I can find the sine of angle A equals the opposite side 21 over the adjacent side 30. I'm choosing not to use that square root of 459. I think it would just make things a little messy. Well, what that means is I could take the sine inverse of 21 over 30, and I'm going to get that measure of angle A. So I'm now found that the measure of angle A equals, and I'm just going to use my calculator here. I'm going to take the sine inverse of 21 divided by 30, and I got 44.4 degrees. Okay, if that one's 44.4, and I'm even going to put it in here, 44.4 degrees. What's my missing angle? Well, there's a angle addition theorem that says all the 3 angles in any triangle have to add up to 180 degrees. So because of that, the A and the B angle have to add up to 90 degrees. So I'm going to just take here 90 degrees minus 44.4 degrees. And what I get for an answer is 45.6 degrees. So that is what the measure, I don't ran out of room here, of angle B is. All right, there's B. Here is A, and then I needed side B here for my angle. All right, so let's look now. Okay, this is our assignment. I want you to do page 310, 28 through 33, and 36 through 39. The answer key will appear on the Moodle. Good luck.